So, welcome to my friends. Today I am going to explain. Basically, this we are working for a motor control. So for the motor control, a three-phase motor control, if it is a two-level inverter, then we need 6 pulses. So there will be 3 sets of complementary pulses for each phase. So this only we are going to generate. So here the modulating signal which is naturally for 3-phase motor, it will be 120-degree aparted. So the ADC will read that modulating signal and it will generate the complementary pulses for each phase. So that is basically the code. So directly I am going to the code explanation. So even though it is not for the beginners, but still I will try to explain. So this is the header file, and here this x, y, z are the 3 variables where the ADC value of the modulating signal will be read, and the variable called duty underscore RC, duty underscore YC, and duty underscore BC. Those are the complementary pulses, the duty cycle of the complementary pulses for R, Y, and B phases. And this TD is the delay time. Okay. Already I explained how to decide that, dead time. How to decide that dead time. You have to read the IGBT or the MOSFET datasheet, and from there only you have to predict this. And how to predict, already I have explained. You can see some in my channel, some of the lectures will be there on that. So this is the main function. This pin configuration, so I am here, this is the pin configuration, pin config function. So if you go there, so these are the 3 timers I have used to generate this PWM. Timer 3, timer 4, and timer 5. So the digital pin 5 and 2, that is for timers 3A and B channel. Then digital pin 6 and 7, it will be timer 4A and B channels, and 46 and 45 will be timer 5 A and B channel. So these are the data direction register I have configured for output. Now coming to the timer initialization. So for the timer initialization, these are the things. So this is the, you can all the bits, how to configure, and what should be the switching frequency. All these things are predicted here in this DCCR 3A 3B, 4A 4B, and 5A 5B. Here only everything's are there, so that you can read the bitwise, read the datasheet bitwise. Then you will understand why I have given this value. Okay. Then I am using timer overflow interrupt. So for that, this status register, the ith bit is to be high, so that's why it is written like this. And to overflow interrupt, to make the overflow interrupt enable, the timer interrupt must register that LSB should set high. So that's why it is written. These are the lines written here, and these are the service routine. These are the service routine for timer overflow interrupt. Okay. Then I am going for the ADC. I am initializing the ADC. So to initialize the ADC, so this is the function. Okay. Already I have explained why it is like this. And to read the ADC, I have used this function ADC underscore read, and here I have used AD marks register. And why it is, already it has been explained in my channel there will be some video on basics of embedded system, so there I have explained it. Okay, so now what I am doing, in the while one loop I am reading this 3 value x, y, this ADC from ADC channel 1, channel 2 and channel 3, and that is stored in x, y and z. So now in output compare register 3A I am giving that x value, which is the x is basically giving the modulating signal for R phase. Then I am subtracting the dead time and that value, because it is a sinusoidal signal, so sometime it will be, that value will be 0. So there, from that 0 if you subtract this dead time, sometime it will go to negative. So that I am restricting it to 0, and then that value I am giving to the channel B. So it is the inverting pulse. So A channel is non-inverting pulse and B channel is the inverting pulse. So similarly this is for channel, this is for timer 4 and this is for timer 5. So this is a simple code. So I am slowly showing the code. So this one, this is the thing. Then it is like this. And then it is like this. Finally it is like this. So this is the code. Okay, so now coming to the simulation. So here you see in ADC, the channel 1 I have given one signal, sinusoidal signal of 50 Hertz, and the amplitude is 0 to 5 volt. Because I have configured the ADC for the reference voltage, you see that analog reference pin I have given it as 5 volt, so that's why. Now coming to the channel 2, here the phase difference, the phase angle is 120 degree, and for channel 3 it is 240. So exactly it is this one. So first we will see the 2 complementary pulses. I'll delete all these things. So for the first, here if you see the timer 3, so that is 5 and 2. So I will connect this to 5 and this to pin 2. Now I will run it. So let us separate it. So blue channel will slightly increase, and you see this is that pulse, and if you coincide together, increase this one. Anytime you pause it, and you see there is a dead time, sufficient, the dead time is there. Now we will filter this too, because this finally it should come sinusoidal signal. We will filter it. So this is the filter. Actually it's a RC low pass filter, simple RC low pass filter. So this I will connect to pin number 5 and this I will connect to pin number 2. You see, if I perfectly, you see, this is giving the complementary pulse. So similarly, if you see for other phases, this will come same. So now the next thing we have to check whether it is exactly 120 degree aparted or not. So for that we will take any sets of, either we will take the non-inverting pulse for all the three phases, or we will take the inverting pulse for all the three phases. So I will delete this. Now these things I will connect to this one, and these things I will connect to pin number 5. Then the next is 6, so I have connected to 6, and then next is 45, so I'll connect it to, where is 45, so this is 45. So this all three signal, it will come as 120 degree apart. It should, these three signals should be 120 degree aparted. So this A is connected to 5. Sorry, this is not the signal. "45" is this one, I think. So pin number is 5, 6 and 46. Sorry. So this should be 46. 46 is this one. Now you see these signals, all the three signals are 120 degree aparted. So let us see whether this time period is coming properly or not. So let us pause it, take a cursor, I'll check the peak to peak. So this is around 18.63 and this should come plus 20. You see, it is like that. So exactly we are able to generate it. So now in somehow, so we will use other controller, standard controller in the market, high speed controller, to calculate all this theta estimation and all the PID, PI regulators, everything it will be implemented there, and finally that controller it will produce the modulating signal, and if that modulating signal is coming to that ADC channel, it will generate very easily the switching pulses for the inverter. So this is basically the concept. So I hope you understood it. Thank you so much. Thanks for your patience.